Good evening, sir. As we discussed in our lab classes that we have to upload the videos and our GitHub repository for our lab worksheets. So for last two labs, the first one is modeling. So we've done the modeling for this object, a pencil sketch of a car, and we have resized this object into 640 by 480 pixels, and we are going to do the model for that. So let's move to the shapes, determination of the shape. As you can see that we have determined all the shapes of a car like semi-arc, circle, window, upper window side is a rectangle, semi-arc, circle, and etc. All the straight lines and all that. And now we have noted down the coordinates for every of them. The coordinates for the semi-arc are not able to be notified because the center are unknown, and also the radius and the start angle and end angle are very difficult to know. If we know the center for that, we can do it. Definitely we can do it, but the centers are not able to know. It's very difficult to calculate centers for that. It's very time consuming. So we have not implemented the semi-arcs, all that. Semi-arcs are this part, these arcs of at the edges. So we're not implemented that. Rest all the arcs we have implemented. So let's move to the coordinates. So basically these are the coordinates for all the circles, shapes and all that. So for starting one is for wheel, second is for door, mid screen and all that for that. And below that we have noted down the syntaxes for that, like circle, line, etc, etc. As you can see, the first circle is 150, 360, the center of the circle, and the radius is 25 pixels. All the notations are in the pixels. And let's move to the compilation to code. So let's compile the code. As you are running in the shell, we must include -l graph. That's a repository for that. Enter. Now we'll run that. So this is output. As I told you that I have not implemented the edges graph, edges arcs. So it's a straight line joining. So it's like a box, but it's not actually like that. It's very difficult to draw. So not that difficult, but it's easy. Not that easy too. So I've tried to implement it as accurate as possible. So like that. And next one is the second task was optimization of DDA. So first let us took a glance at DDA. So this is the basic algorithm for DDA, basic code for that. That's also implemented in C language. So for DDA, we take 2 points, 2 points for drawing a line that's required. We calculate difference between the x coordinates and y coordinates, like x2 minus x1 and y2 minus y1. We took the greater number of greater coordinates from that magnitude wise. Then we start a loop till the greatest number of pixels, like if it's 2, 2 and 5, 3. So 5 minus 2 is 3. The difference between x coordinates is 3 and difference between y coordinates is 1. So we'll take a 3. So number of steps will be 3, and the loop will be incremented every time with a fixed value. The fixed value is calculated at the start of the loop. The constant value is calculated at the start of the loop, and every time you can see here the value is incremented in the loop. X is incremented by x incremented, and y is incremented by y incremented, and that's calculated here. That value is nothing but the original point, the dx value divided by number of steps. So that's calculated every time the loop runs. So like we calculate that value at the start of the loop, and we increment every time it by small. If its value is 1, so every time it will be incremented by 1, and we put that particular pixel, and the line has been drawn. So let's execute this. I implemented a DDA, so let's run it. So you can see that the line is plotting. So every time the loop runs, it's plotting the next pixel, and the same manner the line has been drawn. So turn by turn the pixel has been plotted, and when the line is drawn, it gets exit. So the optimization basically we have done in the DDA is that you can see here, I fixed the absolute value. So not every time it has to calculate the absolute function, absolute value for that. I've just fixed it what to take if absolute means absolute, which what like a round of type. So it's not that confusion, and not compiled every time. So it saved some amount of time. And also here, if steps equals to 0, that means if you input the same point like 2, 2 and 2, 2, it won't go through the whole DDA procedure. It won't calculate the number of steps and all that. It just runs the if condition, and it will be exited. So basically, if 2, 2 and 2, 2 has been entered, the steps will be number of 0, that is only 1 point. So 1 point will be plot, and output will be given, only single point has been plot, and the program will be terminated. So these are the optimization I have done, and also I have tried to implement a circle using the DDA. So here is that. This is the code for circle. We are taking input as the center of the circle and the radius of the circle. Then we are plotting the axis. The axis very required for that we can fix the reference as a reference. So as a window size is 640 by 480, so we are plotting the axis for that 0, 240, 640 is the endpoint, and 240, and 320, 0, 320, 480. Then we are passing that value to DDA circle function. It's incremented, it's calculated, it's also incremented in the same manner, but just the difference. So the difference is instead of incrementing by random value, means not in singular value. It's the incremented value is calculated every time and it's incremented by power 2 comma. A circle is a circle is a hyperbolic function like math function, so it should increment like a symmetrical manner. So it's incremented in the power of 2 comma I. So every time the I value increments, the value of power is calculated, and in that manner, the x and y value is incremented by calculating the function like x2 is equal to previous point plus that value, and we are plotting the pixel. So let's run this. So let's compile the circle. So we have to enter the center 2 comma 2, radius is 100. So we are getting the circle here. So you can see that the axis has been plotted, and we got the final output as circle. We have to enter the coordinates and the radius for that. So that's all I've implemented for the 2 lab sessions. I hope you consider it, and I hope you find my work interesting and decency. It's 100% authenticate. You can check that, and I'll upload this. Thank you, sir.